This is not a normal sunset. On August 12, 2026, the sun will already be dropping toward the horizon. Then, the moon will cover it. For a few minutes, along one narrow line on Earth, sunset will turn black. That line crosses Greenland, Iceland, northern Spain, and a small part of Portugal. But almost everyone outside it will miss the real event. They may see the sun partly covered. They may see the light fade, but they will not see totality. And even inside the path, 2026 has a problem most eclipse maps cannot solve. The sun will be low. The horizon will matter. Clouds will matter. A hill, a building, or a few degrees of haze could decide whether someone sees the event of a lifetime or watches an ordinary evening swallow it first. It is a race against the horizon. A total solar eclipse is brutally selective. From space, it looks simple. The moon passes between Earth and the sun, and its shadow falls onto the planet. But on the ground, that shadow is not everywhere. It is a moving corridor. Step outside that corridor, even by a small distance, and the eclipse changes completely. You might see the sun partly covered. You might see the light dim. You might notice the air feels strange, but you will not see the corona, the ghostly outer atmosphere of the sun. You will not see the black disk hanging in the sky. You will not get totality. That is the first trap. Millions across Europe, North America, and North Africa may see a partial eclipse. But totality belongs only to the narrow path. For this event, that path runs across remote Arctic regions, Greenland, Iceland, the North Atlantic, northern Spain, and a small part of Portugal. The shadow is enormous in meaning, but tiny on the map. The 2026 eclipse has a special place in Europe. It will be the first total solar eclipse visible from mainland Europe since 1999. That alone makes it a major event, but the geometry is awkward. In Spain and Portugal, totality comes late in the day. NASA notes that in Spain and the very northwestern tip of Portugal, the sun will not be fully eclipsed until late evening, shortly before sunset. That means the eclipse will not be high overhead. It will happen low. Low enough that the shape of the land could matter. Low enough that the western horizon becomes part of the story. Low enough that a perfect eclipse path on a map may still fail in real life if the view is blocked. That is why this is not just a where to watch question. The real question is harder. Can you catch totality before the sun disappears for good? Farther north, the shadow crosses Greenland and Iceland. On a map, these places look cinematic. Ice, volcanic rock, black coastline, open sky, a shadow moving across the edge of the North Atlantic. But beautiful does not mean easy. Greenland is remote. Iceland is famously dramatic and famously weather-dependent. Cloud cover can turn the most perfect eclipse path into a grey sky. For eclipse chasers, the map is only half the problem. The atmosphere gets a vote, and that is what makes 2026 fascinating. The event has two different kinds of difficulty. In the north, the problem is weather and access. In Spain, the problem is the low sun and the horizon. The moon's shadow will be exact. The orbit math is predictable. The uncertainty belongs to Earth, clouds, mountains, coastlines, cities, human planning. For a cosmic event, the final obstacle is painfully local. During a total solar eclipse, the moon's dark inner shadow, called the umbra, touches Earth. That shadow does not sit still. It races across the surface as Earth rotates, and the moon continues its orbit. For the people inside it, the change can feel impossible. Daylight weakens, colors flatten, shadows sharpen, the temperature can drop. Birds and insects may react as if evening has arrived early. Then, at totality, the last bead of sunlight disappears. For a few moments, the sun's ordinary face is gone. What remains is the corona, pale, tangled, and normally invisible because the solar surface is far too bright. Every total eclipse is a temporary instrument. The moon becomes a natural coronagraph, blocking the sun's disk so the outer atmosphere can be seen. But in 2026, many viewers in the path will see that moment against an evening sky. Not noon darkness, sunset darkness. The title sounds simple. The 2026 eclipse will turn sunset black. But the reality is more demanding. The path is narrow. The duration is short. NASA says that for most people in the path of totality, the sun will be fully eclipsed for less than 2 minutes. Less than 2 minutes. That is the entire window. Arrive in the wrong place and you get a partial eclipse. Stand behind the wrong obstruction and the low sun may be blocked. Get unlucky with clouds and the sky may hide the event entirely. That tension is why the 2026 eclipse is such a strong story. The math is ancient and precise, but the experience is fragile. Somewhere the moon's shadow will cross Earth exactly on schedule. The question is whether human eyes will be in the right place, with the right horizon, under the right sky, at the right minute. We do not have footage of the 2026 totality yet. It has not happened. But we do have footage from earlier eclipses, including the total solar eclipses of 2017 and 2024. Those videos show what totality does to a crowd. The shouting, the silence, the sudden night, the white corona around a black sun. Use those images carefully. They are not the 2026 eclipse. They are a preview of the physics. The same alignment will return. The same kind of shadow will fall. But the place, timing, weather, horizon, and human experience will be different. That difference is the point. The 2026 eclipse is not just another copy of 2024. It is a new arrangement of the same cosmic machinery, aimed at a different part of Earth, arriving at a stranger time of day. There is another reason this eclipse matters. The sun is not a static object. Its magnetic field twists, snaps, and reorganizes. Solar activity rises and falls in an approximately 11-year cycle, and around solar maximum, the corona can look more complex and dramatic. By 2026, the sun will still be close enough to this active period that eclipse watchers may see a corona shaped by a restless star. That does not mean anyone can promise a specific shape. The corona is not staged for us. It is physics, unfolding in real time. But it does mean the eclipse is not only a spectacle, it is also a moment when the hidden outer atmosphere of the sun becomes visible from the ground. The same sun that drives auroras, solar storms, and space weather will briefly reveal the structure that normally hides in its own glare. There is one part of this story that cannot be softened. A solar eclipse is not safe to stare at during the partial phases. Certified solar viewers are required whenever any part of the bright sun is visible. Only during totality, and only from inside the path of totality, can the sun be viewed without eclipse glasses. The moment totality ends, protection has to go back on. That matters even more with a low sun. A sunset eclipse may feel less dangerous because the sun is lower and dimmer. But dimmer is not the same as safe. The event is beautiful because the alignment is exact. It is dangerous for the same reason. On August 12, 2026, the moon's shadow will find Earth again. It will cross ice, ocean, volcanic coast, city, field, and horizon. Most people will miss totality by distance. Some will miss it by weather. Some may miss it by a blocked view of the setting sun. But along one narrow line, for less than a few minutes, the ordinary world will do something impossible. The sky will dim, the horizon will hold a black sun, and sunset will arrive, wearing the shadow of the moon.